Hello everyone. The next acidic comparison will be this. This is 2-nitrophenol, already discussed with you in previous video. First position will be this, given to main functional group. Second position will be given to side chain. 2-nitro, and this is whole portion, 2-nitrophenol, or we can call it orthonitrophenol. Similarly, if I number 1, 2, 3, 4, so 2,4 dinitrophenol, IUPAC naming. Its name will be 2,4,6 trinitrophenol. And this compound's common name is also picric acid. Picric acid. Common names are always very important in organic chemistry. So make a separate notebook and write down all the common names of the compounds with their chemical formula. This is picric acid. This is ortho-para-nitrophenol, and this is orthonitrophenol if I talk about common names. So let's compare their acidic nature. Again, I am using the second method to compare their acidic nature. Means I am checking stability of the anion which is left after removal of H positive ion. I have removed H positive ion and I have made anion there. This one, anions are made there, and now let's check whether they are getting stable or unstable. Which atom is unstable? Oxygen, because it is carrying a negative charge. Now which factor its negative charge is increasing or decreasing? Let's check. Factor number 1, this resonance, which we used to call plus R of oxygen. Yes, it is showing plus R effect because due to resonance, it is donating electrons in a benzene ring. And as already I told you, what is plus R effect? Loss of electrons due to resonance. So with plus R, the negative charge of oxygen will finish. Draw resonance by yourself. First structure at least. This factor is also available here. This factor is also available here. So only this factor can't decide the acidic comparison or stability order. Second factor. From ortho position, you know nitro group can absorb electrons which are coming from resonance. So means from ortho position, nitro will show minus R effect. Now in this molecule, nitro is present on ortho as well as on para, and we know from both positions it can show minus R effect. So I will write minus R effect 2 times. Minus R, minus R. And here you can check nitro group is present on 3 positions. This is ortho, this is para, and this is ortho. And from all 3 positions, it can show minus R effect, means it can absorb electrons which are coming during resonance, this resonance. Because during resonance, the lone pairs will generate on ortho and para positions. Please check previous videos. So here minus R effect will be how many times? 3 times. Of which group? Nitro group. And nitro group is substituent here. Third factor, nitro group is more electronegative than carbon. Nitrogen is more electronegative than carbon, so it will attract electrons. And as it will attract electrons, this effect will be operated up to here, due to which the negative charge of oxygen will decrease. Means minus I effect. This effect is known as minus I of NO2. Attracting electron due to electronegativity difference is known as minus I effect. Losing electron due to electronegativity difference, that is known as plus I effect. Here minus I effect is also there. How many times? 2 times you can check, because 2 nitrogen groups are there. In this case, how many times minus I effect will be there? 3 nitrogen groups are there. Nitrogen atoms are there which are attracting electrons due to higher electronegativity as compared to carbon. So 3 times minus I. That's it. All the factors we have written. Now it's a time to conclude. Okay. So if I say in which case the negative charge of oxygen is decreasing most, so the answer will be this case. Third case. It's the first one, it is second one, and it's the third one. Because you can check the oxygen negative charge is decreased by 3 factors. Number 1, plus R of oxygen. Number 2, minus R 3 times. Here also we have minus R effect in these cases, but here only 2 times and here only 1 time. So 3 times. Number 3, minus I effect 3 times from 3 positions, 2 ortho positions and 1 from para position. So obviously the negative charge of oxygen is decreased most in this case, followed by second. You can check here 3 times minus R effect. Here now we have 2 times minus R effect. Here 2 times minus I effect. So here the negative charge of oxygen is decreasing but less than third one. So third is most stable, followed by second, and least stable anion will be first one. No doubt negative charge of oxygen is decreasing by these factors, but as compared to this, it is less decreased. And if I talk about this one, negative charge is decreasing, but as compared to this, it is decreasing less. So the stability order, if I write, I am rubbing it. In this fashion, always write down the factors. So stability order of anion, increasing order if I write. So first one is least stable, second one is more stable than first, and third is most stable. And if I write acidic nature of their molecules, means those molecules which have generated them by the loss of H positive, like this was orthonitrophenol, this was orthoparanitrophenol, and this is picric acid. So which is most acidic? Third one will be most acidic, because it knows that after loss of H positive, the anion which it is getting, it is most stable anion. So obviously everybody wants stability. So it is the happiest molecule to release H positive, because it knows that after release of H positive, I will get stability, I will get stable anion, most stable anion. So it is ready to release H positive easily. If it is ready to release H positive easily, means it is most acidic. So first will be least acidic compound, means orthonitrophenol. Second, orthoparanitrophenol will be more acidic than orthonitrophenol. And third, picric acid will be the most acidic compound among all these three. I have applied the second method. I am checking the stability of anions which is left after removal of H positive. You can apply the first method also. Check the strength of OH bonding and you will find same order. Please try it. As a student, you must try all the ways to solve the questions because you are very new in the concepts. Thank you very much. In next video, next comparison.